Hello, everyone. In this lesson, we will take a CNC milling part as an example to reinforce the learning of manual measurements using a coordinate measuring machine. For some complex parts, traditional measuring techniques often require a large number of manual measuring tools. This not only lowers efficiency but also makes it difficult to ensure accuracy. Coordinate measurement technology is one of the most effective methods for measuring and obtaining dimensional data. It can replace multiple surface measurement tools and expensive combination gauges, reducing the time needed for complex measurement tasks from hours to minutes while quickly and accurately evaluating dimensional data and providing operators with useful information about production processes. With the rapid development and widespread application of digital and CAD technologies, the integration of coordinate measurement technology with software is becoming increasingly close. The use of CMMs is expanding, so it is essential for us to fully grasp the measurement functions of CMMs and make better use of their capabilities. Today, we will not only learn this technology but also draw inspiration from the story of a great craftsman, Yang Jinan, and his team, who overcame the challenges of special steel smelting for the Datangsia Water Conservancy Hub. Steelmaking is a meticulous task, more patience demanding than embroidery. Yang Jinan has worked on the front line of heavy equipment manufacturing for 36 years.
Surrounded by steel sparks and furnace slag,
He has smelted aerospace steel, aircraft carrier steel, nuclear power steel, and more, repeatedly achieving breakthroughs in the industry and contributing to major national projects. Through their efforts, they show us the essence of craftsmanship, the pursuit of excellence in every task. Now, let's begin our lesson by covering the following key areas. Through this lesson, we hope that each of you will be able to independently complete the CMM measurement task for CNC milling parts, including key steps such as preparation, probe selection, part clamping, program editing, and part alignment, ensuring both the accuracy and efficiency of the measurement results. Now, let's analyze the measurement requirements for the CNC milling part according to the drawing and complete the establishment of the coordinate system. The first step is to carefully analyze the part to familiarize ourselves with the inspection content and create a measurement dimension table. Upon reviewing the drawing, we see that the reference points A and B are clearly provided. Based on the principle of reference overlap, when establishing the coordinate system, priority should be given to using these reference points for alignment. Just like Yang Jinan, who adhered strictly to benchmarks and principles when refining special steels, constantly pursuing technical perfection to ultimately produce the required special steels. Similarly, we must also follow measurement principles to ensure the accuracy of every data point when performing part measurements. After carefully reviewing the drawing, we organize the 12 measurement dimensions, associated features, nominal values, and tolerances into a table for easy and quick reference during measurements. The second step is measurement preparation. Yang Jinan, when refining special steel, also needs to carefully prepare and select raw materials to ensure that every step meets technical requirements. His team worked together to overcome the challenges of steel refining. Similarly, when conducting part measurements, we also need to prepare carefully, ensuring that the measurement equipment, probes, and part clamping all meet technical requirements to obtain accurate measurement results. First is the probe selection. This is based on the laboratory's existing equipment and the required measurement feature size range. Here, based on the feature distribution on both sides of the part and the required measurement size range, it is noted from the drawing that the smallest hole diameter to be measured is 17 mm, and the smallest slot width to be measured is 8 mm. Therefore, a probe with a diameter of 3 mm and a length of 40 mm is selected. Based on the distribution of measurement features, 3 probe angles are added: A0B0, A90B90, and A90B90. Next is the part clamping. To ensure that all required dimensions are measured in one clamping, This case recommends side clamping of the part, with the solution using hexagon's flexible fixture. The relative posture of the part to the measuring machine is shown in the figure. The clamping steps are as follows. 1. Use 2 support pillars to support the bottom surface of the part. 2. Use the spiral pressing block to clamp the top surface of the part. 3. Complete the alignment and clamping of the part. Now let's look at the actual operation. 1. Create a new measurement program, name it student number 4, set the units to millimeters. Enter the program editing interface. 2. The program parameters should follow the reference from task 3. Position the cursor on the probe location. Press F9 on the keyboard to enter the probe editing interface. Sequentially select the probe seat, probe, adapter, and probe model. Then click to add an angle. Add 3 probe angles, A0B0, A90B90, and A90B90. The probe verification should also follow the previous task steps, ensuring that the configured and verified probe file is as shown in the figure. Click Results to view the error values of each probe angle. If the error exceeds 0.01, the probe needs to be recalibrated. Next, the part alignment. In the program, call probe A0B0, and touch 2 points of equal height on the left in-face of the part to obtain measurement point 1 and measurement point 2's measurement commands. Compare the actual x-coordinate values of the 2 points. If the absolute difference between them exceeds 0.1 millimeters, the part position needs to be adjusted and remeasured until the absolute difference between the actual x-coordinate values is less than 0.1 millimeters. After the part alignment, delete the alignment measurement points. In this course, using CNC mill parts as an example, we delved into the manual measurement technique with a coordinate measuring machine, CMM. Through the steps of part analysis, organizing measurement dimensions, preparation, part clamping, and actual operations, we learned the fundamental steps and skills of coordinate measurement. We also drew inspiration and strength from the story of the great national craftsman, Yang Jinan, and deeply understood the spirit of excellence and teamwork. I hope that in your future studies and work, you can continue to maintain an exploratory spirit, the sense of responsibility, and the professional ethics of a national craftsman, constantly improving your professional competence and practical abilities. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This lesson ends here. See you in the next lesson.